Today's activity is going to be not unlike the last activity you did in a lot of ways, but it is going to be a little bit unlike the activity you did last time in that it's going to involve acceleration as opposed to constant velocity. So you can see the apparatus that's set up right here is almost the same as what you had last time, except that we don't have a motorized cart that's going at a constant velocity. Rather, we have what we call a dynamics cart, you can see right here, that's designed to move along the tracks or to move along the grooves of a track. Now, the reason that we do this is so that we can elevate one end and have it accelerate as it goes down the hill. So, this is how we're going to do this. We're going to break up into groups in a few minutes here, and we're going to have 4 groups going at a time. 4 groups will go, 4 groups, or the other groups will be working on something at their desk, and I'll explain that in just a moment here. The 4 groups that are going to take a track. You see the tracks up here. There's 3 short ones and 1 long one. They're going to elevate that track, not to a really steep elevation. Okay, you see that I've got a couple of DVDs underneath the short track there. Okay, that's all you want. You don't want 6 books underneath it to make it a 45-degree angle. It's going to go down that track too fast, or at least fast enough that it's going to become difficult to get good data for that. Okay, you want it to accelerate down the track, but not at a huge rate, not at 9.81 meters per second squared. So you've got the track kind of lifted up there by some DVDs or a book or a couple of books or whatever. Then you've got the dynamics cart on the track. Okay, and then you've got the motion sensor. It's actually attached to the track. And if you have a little bit of trouble with that, then I'll explain once you actually get your apparatus in your hands how to attach that motion sensor to the track. Now, of course, attached to that motion sensor is going to be your spark view or your AirLink sensor. Okay, this is an old picture. This is the apparatus that we used last year. It's going to be essentially the same this year, except that this is replaced by that AirLink that you're going to attach via Bluetooth to your iPods or your iPhones. Make sense? Now, I'm not going to go through that procedure of attaching it to your iPhones again. Okay, those instructions are on a piece of paper if you forget how to do that. And I'm always here to help you individually if you're having a little bit of trouble pairing it with your iPhone as well. Remember that when you do pair it with your iPhone and you do set up your experiment, sometimes it seems to want to measure the acceleration of your iPhone. It uses the internal accelerometer of your iPhone. That's not what we want. Okay, we want to see position. That's what we want to measure here, is position. Make sense? So, if it's not showing up as position, okay, remember that drill that we went through last time? We delete the experiment by swiping it and clicking delete, and then we turn off your iPhone, and then we turn it back on, and 99 times out of 100, it seems to be fine when we do that. Got it? All right. This time, I know last time, a couple of people, when they typed over or when they transferred their data into Microsoft Excel, we had time on in the first column, and we had position in the second column. A few people last time kept the velocity in the third column. We didn't want that last time. This time we do. Okay, this time we want the 3 columns. We want the time, the position, and the velocity. If, by the way, you delete the position, that's okay, because we don't actually need it, but it's also okay to leave it there. Okay, the 2 things that we want are specifically the time and the velocity. What do you think we're going to do with it after we've got our data of time and velocity emailed to ourselves from our iPhones? What comes next? You guys know what comes after a data table, right? It's going to be plot a graph. We're going to plot a graph of velocity versus time. That graph should give you a straight line graph. Sorry, quick little correction here, guys. We do need all 3 of these. Time, position, and time, position, and velocity. We go to our analysis. We're going to plot 2 graphs. Our position versus time, which should look something like this, and our velocity versus time, which should look something like this. Then you're going to answer 3 analysis questions. The first one is describe the motion of the object using the position time graph referencing the shape of the graph. So look at this and tell me what's happening to the object. Is it going at a constant velocity? Is it accelerating? Is it decelerating? Is it going backwards? Okay, describe the motion of it and then justify it with the graph. So how do you know, basically? Look at this graph and tell me, well, the shape of the graph is this, so it indicates this is happening. The second question says, calculate the acceleration of the object using the velocity time graph. So with this graph, get the value of the acceleration. Got it? Get the value of the acceleration. And we're not going to worry about question number 3 here. What was the problem here? Well, to find the acceleration of this cart. So what's your conclusion? What is the acceleration? Write down what the acceleration is. Essentially the answer to question number 2 there. And then how do you know? Your sources of error. Again, you want to list 2 or 3 good sources of error and ways to improve it. Yeah, Travis? How do you get the slope of it? You can do that on Microsoft Excel, and I can help you out with that in a little bit here. Or you can do it by hand, by drawing your line of best fit, picking 2 points on the graph, and then just doing rise over run. So I don't care whether you do it with Excel or whether you do it by hand. Most people will probably end up doing it with Excel because it's so much quicker. Yeah, and I'll show you how to do that individually. What do you got to hand in on this? Well, essentially the same thing as you did on the last one. Okay, we will, as more and more activities happen, we will do more and more, like a problem, like a hypothesis, like a procedure, and so on. But I want to focus on a couple of things at a time so that we can master those before we start doing more things. Okay? We want to master data, analysis, conclusion, and sources of error, and then we'll take a look at writing down the problem. Then we'll take a look at writing down your materials and your procedure and all that kind of stuff once we've mastered what we've been working on the last couple of times. Any questions? All right, we'll get at it.